Hello, everybody. Thank you for signing up for our second webinar about containers. Hopefully, as you can see the slide currently, my name is Steve Miller. The title of this webinar is Demystifying Container Backups. I hope over the next 15 minutes or so, we'll go some way towards, if not demystifying container backups, clarifying what part of a container-based infrastructure needs to be backed up and how that might be achievable. So I'll just quite quickly like to show you our agenda for today. As you can see, we've got three things that we're looking to cover. The first one is a quick discussion of how containers are different to other workloads. If you work in this industry, you'll likely be bombarded daily with messages about how containers will change everything. I'm not going to make that claim as part of this session, but I do want to discuss the potential that they have for change. Secondly, we're going to discuss when a container needs to be protected. As you'll probably know, Predatar has cut its teeth in the data protection industry. That's been how we tend to approach new technology. How and why should it be protected? As I've already suggested, container workload is different to traditional workloads. That doesn't mean that all traditional considerations get thrown out the window. There's reasons why you need to protect environments, and those reasons still apply here. And finally, we'll end with a broader discussion around containers. As I said, we've been told that they're the future of IT, so we're going to consider some of the key players in this technology space and look at a very high level at the differences of some of their offerings. But first of all, we're going to have a history lesson. As I said, we're going to discuss how containers are different to traditional workloads. So this diagram shows the Predatar data center over time, and we're going to start with the mainframe. Now, in this environment, you would have a mainframe with, for its time, massive amounts of processing power spread out across the data center floor with huge chunks of spinning disk and similar amounts of air conditioning to stop everything from overheating. You have lots of business critical data stored within that mainframe, and that data would be protected by making duplicate copies of data sets and later on by using backup applications to push a second copy out to tape. I remember taking hundreds of those backup tapes to disaster recovery sites to stand up a copy of the mainframe and prove that the data and business was protected. Even then, backup was key. And then people moved to a client server based infrastructure. Instead of a mainframe or two, they had a server or 20 or 200. Each of these servers provided a different role to the business. Some of them were more important than others, but most of them still required protection. And instead of having multiple backup applications everywhere you had a server, this is where the big backup products came into their own. Products like TSM, Commvault, and NetBackup started consolidating backup data from multiple different platforms and multiple operating systems into one unified backup repository. And then we saw the rise of virtualization. Instead of tens of servers, we saw organizations with hundreds or thousands of VMs. Instead of having to wait for your supplier to supply you with a server and for your data center staff to cable it and install it in a rack, application developers could spin up a VM in less than an hour. New modes of backup meant that it was easier to protect those workloads efficiently and to recover them quickly. And of course, by now, businesses expected their infrastructure to be always on, and the amount of downtime that would be tolerated became less and less. And finally, we get to containers, where we are now. Kubernetes has got clear benefits for organizations, such as allowing more efficient utilization of resources and greatly shortening software development cycles. But although it's a technology primarily used at the moment for DevOps workload, it's still the province of early adopters. We've been told that we're going to move to an infrastructure where we can have thousands of containers, maybe tens of thousands existing at any one time. Depending on demand, some of those containers might exist for small amounts of time. In this infrastructure, how do you know what needs protecting? And how would you be able to recover? Okay, we're going to dig into this slightly more deeply. We've chosen to show this using our bubble machine. Now, each time there's an activity that needs a container, it produces another bubble. And the bubble machine output is dependent on the input. So when there's not a lot of data to work with, then the quantity of bubbles remains relatively small. But if we crank up the input, the bubble machine scales to cope with the increased amount of data, and you've soon got lots and lots of bubbles, each one performing a particular function on a particular subset of your customer data. So where does that end up? Well, have a think. Before long, we end up in a cloud landscape populated by hundreds or thousands of disparate bubbles. And trying to back them up is really difficult. It's like trying to catch a bubble in a net. It's difficult to do, and just when you think you've managed to do it, your bubble gets popped. Anyway, so much like the bubbles, you don't want to back up a container. The container is an entity there to perform a specific function. The quantity of containers is dependent on the amount of workload that you're sending to them. Containers might spin up to replace a container with an issue, or they might scale up to cope with an increase in demand, but they might shut back down before there's a chance to even consider backing them up, let alone trying to do so. Of course, that doesn't mean that none of the infrastructure needs backing up. Over the last few years, we've seen closer integration between containers and the storage that is presented to them. Now, obviously, standard container storage is just as transient as the containers themselves, so it'll disappear as soon as the container disappears. But although that container might be stateless, if the service running on it is a stateful one, the data on it will still be important after that container goes. The data will be stored on persistent storage using the container storage interface. From a data protection point of view, this is where things get interesting. Rather than worrying about protecting individual containers, we think there's a need to protect the data that's presented to them using that persistent storage. And we're not alone. If you look at the backup products that are working with containers at the moment, they're mostly concerned with ways of backing up this storage. And various cloud providers working with Kubernetes have got persistent storage that has data protection options built in. But it's not all about those persistent storage. The containers themselves might not merit backup consideration, but maybe you should consider whether you need to protect the configuration environment as well. So this is slightly more complicated, depending on whether you have full control of your Kubernetes cluster. It might not be available in a public cloud offering, but if you're managing your own cluster in hybrid cloud, you should look at some of the backup products that are available to help you protect it. It's not just a point with regards to Kubernetes, by the way. It's often the case with public cloud that flexibility comes at a cost, and that cost might be that you lose full control of the environment. But back to backup, you should look for a product that lets you protect that configuration environment, specific information, specifically the etcd cluster info. Obviously, you can protect this information manually, maybe set up a cron job. But if you want to make it more resilient and make it more automated, there's products available that can help you do that. And for persistent storage, there's several backup product providers available. You can use products such as Valero, Kasten.io, or IBM Spectrum Protect Plus to protect the storage within a Kubernetes environment. Now, I think it's fair to say that the backup ecosystem for Kubernetes is yet to mature. There's still some discussion around whether organizations even need to protect those environments. But as the technology moves away from being the province purely of the application developer and towards more generalized use, the applications and the data in them will become more and more critical, and the requirement to protect it is going to be more urgent. Here at Predatar, we've done some initial testing with one of those products, and we're going to continue those tests over the coming months. If you do want to discuss that further, then please reach out to us after this webinar has closed. Away from backup for a while, one of the questions that was asked at the end of the previous webinar is, what does the future hold for Kubernetes? If it's going to become this mass movement that transforms IT, then it does need to become a lot less specialized, become more applicable to a broader section of the market. In the VMware State of Kubernetes 2020 report, 70% of respondents said that a lack of expertise was the biggest challenge for Kubernetes deployments, and 64% of respondents said that ease of use was top of their criteria when selecting a Kubernetes distribution. As that report says, it's critical that Kubernetes is packaged in a way that simplifies enterprise adoption. We agree with that, and although that enterprise adoption might be a year or two away, I think we need to watch those leading vendors as they try and put their flags in the ground and claim the territory as their own. So if you look at some of the strategic moves over the last year or so, it's pretty clear that IBM and VMware are lining up their tanks for this particular battle. In the blue corner, IBM acquired Red Hat a year or two ago. Part of that reason is because Red Hat has a more compelling story with hybrid cloud. That's because they've been using OpenShift as a way for organizations to manage hybrid cloud installations for a number of years. Now up to version 4, OpenShift has thousands of companies already using it as a way to manage container-based environments, both on-premise and in public cloud. It's a mature piece of software with a broad feature set, and it gives IBM much needed credibility in this space. And then we've got VMware coming up on the rails. Now, VMware is a very interesting player in this area. Everybody knows that VMware is the market leader in the virtualization space with a huge install base. They made an acquisition, again, a couple of years ago, of a company called Pivotal. This was much quieter than the IBM Red Hat acquisition, but you can see it as being in a roughly similar direction. They've been using the collateral that came with that acquisition to strengthen their offering in the container environment since then. First evidence of this was the Tanzu Management Console, available last year. And with the announcement of vSphere 7 a month or so back, they brought this more completely into the latest edition of vSphere Cloud Foundation. Now, if you look at the feature stack for these two products side by side, it can be difficult to see the wood for the trees. OpenShift will be better at certain elements, whereas VCF will be better at others. And of course, there's a third option, to use neither of them, and to continue to manage a Kubernetes environment with your own tools. At this moment, I don't think we can look at these two offerings and suggest that one of them will grab the market share from the other. If you're looking for a platform, for instance, that supports a wide range of operating systems, you might want to give more weight to VMware. If you're concerned about the quality of the storage and network integration, you might move towards OpenShift. So each of these two big hitters will be chipping away at each other for the next while as they try and build up their voice in this arena. I saw an announcement last week that mentioned how Red Hat was also adding more support for virtualization into OpenShift. So although these two companies are coming at it from slightly different directions, they're both trying to position themselves with authority as the platform that can support all workloads and all flavors of hybrid cloud. IBM and Red Hat can point to the evidence of the user base already using OpenShift and say, well, we're partway there, but that's dwarfed by the user base for vSphere. And it has to be a consideration that as organizations move to vSphere 7, it may end up being the de facto cloud management platform along the way. Even then, an organization needs to make a conscious decision to go there. VCF isn't the default offering for vSphere 7, nor is it a low-cost one or a simple one. Basically, each organization that is considering one of these two products should weigh up what their business needs from it and see which of them, if either, best supports those needs. If you already use Enterprise vSphere VMware and are looking to add containers and hybrid cloud into the mix, maybe VCF is the way to go. If not, you might see benefits in Red Hat. But if your application development teams tell you that there is no need to make a decision yet and that the business doesn't need you to adopt one of these, well, you might want to listen to those guys. Whichever way you go, it feels like the market is heading for an inflection point, and the talk about this technology is only going to get louder. If you'd like to keep in touch with Predatar as we continue to share our thoughts, please follow our LinkedIn page or our Twitter feed, which, as you can see, is @PredatarUK. Or as always, if you've got any comments or questions, feel free to drop me a mail using steve@predatar.com. I'd like to thank everybody for listening to this webinar. If you've got any questions or any comments, please do let me know using the email address on the screen now. Thank you.